So that's the two ways that enzymes can work. They can either break the substrate down into smaller pieces, or they can take a couple of substrates and bind them together by fitting both into the active site. So there's a bunch of factors that can affect how quickly an enzyme can work. The first one is enzymes or substrate concentration. So if we have a lot of substrate available, the enzyme's going to be able to work quicker because as soon as it catalyzes one reaction, it's just going to be able to pick up another substrate and have it happen. But if there's not very much substrate around, the enzyme is not going to be able to pick up the substrates and do it as quickly. So as we increase the number of enzyme and increase the amount of substrate, the enzyme is going to happen or work quicker, depending on the amount of enzyme and the amount of substrate. The enzyme will eventually reach a maximum speed when all of the active sites are filled. So let's say there's 10 enzymes and there's 100 substrates. The enzymes can only catalyze 10 reactions at a time because there's only 10 of them. But if there were 5 substrates and 10 enzymes, they would only be working as quickly as the amount of substrate allows. Then we have optimal pH and temperature. So both of these affect the shape of the active site, and the substrate cannot bind effectively if pH or temperature has changed the shape of the active site. So pH far from 7 will change the shape of the active site, the substrate can't bind. Too high a temperature will cause the protein to denature, as we've talked about. So the hydrogen bonds between different parts of the protein would be broken down, the active site will no longer be the same shape, and the enzyme can't carry out its job. Some prokaryotes live in extremes and use alternative forms of enzymes to be successful. So there are some bacteria that live in hot springs, and they have enzymes that are capable of working at very high temperatures. So right here, trypsin is a molecule or an enzyme that functions best right around just above neutral, right at 8. That's its maximum speed. However, there's this molecule named pepsin, which works inside your stomach, and its optimal pH is much lower, around 2, because that is the pH of your stomach. So it has evolved to work best inside your stomach. Then we have these things called enzyme cofactors. Enzyme cofactors are molecules that some enzymes need to function. So these enzymes require the presence of an inorganic or non-protein at the active site. So in addition to the substrate, they need this other thing called the cofactor. And this is inorganic. So it's something that's not an organic molecule. And they participate in the reactions. So they will help the reaction happen. If it's not there, the enzyme will not be able to carry out its job because it needs the cofactor to happen. If it is an organic molecule, it's called a coenzyme. Does the same thing. The enzyme needs it to happen, but if it's non-organic, it is called an enzyme cofactor. And then lastly, we have enzyme inhibition. And I know you guys remember this. So there's two kinds of enzyme inhibition. There's the kind called competitive inhibition, in which case the competitor binds directly to the active site of the enzyme. So it binds to the active site of the enzyme, then blocking the substrate from binding. So it's like if two of you guys want to sit in the same chair, both of you can't fit there. If the competitor sits in the chair, you are not going to be able to sit in the chair. However, there's also non-competitive inhibition or allosteric inhibition, where the competitor instead binds to the allosteric site. So any molecule, the inhibitor, in this case it's a product, binds to the allosteric site, changes the shape of the enzyme, changes the tertiary or quaternary structure of that enzyme, so now the active site has changed shape, so the substrate can no longer bind. So those 5 things: substrate concentration, pH, temperature, cofactors, and inhibition are what can affect the speed of enzyme reactions.